the perennial forbs increased greatly on the encroached site. So what's really going on here is it seems that the PJ sites are having a much greater response to these treatments. Most likely their understories were modified greatly due to many years of the pinyon juniper dominance. We can also look at this with grasses. The grasses really didn't change. You know, overall grasses changed after 7 to 9 years, but these two different types of ecological sites, they didn't differ in the pre or the post. So that gives us a little bit more understanding of how different ecological sites might be operating. Now, we have 32 ecological sites, and we're pooling things here. For someone who really wants to get down to how different ecological sites respond, I think it's there. I think we have the capacity to do that. And that's what makes this exciting, is that we can just keep drilling down into the data set to learn as much as we can so we can be more predictive. Like say, oh, I'm on this type of ecological site, this is what might happen based on this data set. So we're making decisions based more on the data. That's where we really hope that this will take us. So seeding, we wanted to know, are there differences? Is there a difference if you seed or you don't seed? That's really what it boils down to. Okay, and once again we're looking at the pre-treatment versus, in this time frame, it's just the one that was the most dynamic. Okay, and so looking at, sagebrush was seeded, but you can see in the pre-treatment there really wasn't much difference between the seeded and the non-seeded, and then you take that out 3 years, even though these were seeded, they're still not different. So we kind of already knew that sagebrush isn't changing that much. Another interesting thing to look at would be the perennial forbs. Same kind of a story here. So in the pre-treatment, we couldn't find a difference between seeded and non-seeded sites, and nothing really happened post-treatment either. And here's an interesting one here with the perennial grass. We already know that a lot of the grasses that were seeded established. I mean, that's one of the big take-home messages here, is that the seeds are establishing, they seem to be good species, a lot of them are native, and they're establishing on these sites. In the pre-treatment, they were chosen to be seeded because they had low grasses, okay? I mean, oftentimes during the site assessment, you say, do we need to seed this site? And you say, well, it doesn't have a lot of grasses, we should seed it. So that's what you're seeing here. But the interesting thing is that over time, within about 1 to 3 years, you can see it increase to match the level of a site that was deemed not needing to be seeded. So, just looking at the vegetation, I'm thinking, wow, there's some good things that are happening here, but you're also probably thinking, economically, we're getting a lot of bang for the buck here. You're spending a lot of time and money seeding, and you're getting some responses. You're changing landscapes in an important way. And so that kind of moves me into just a couple conclusions, and I'm going to touch on my last subject, and that is the success of some of these seedings, where we kind of drill right into the data set and we look at specific species, and we want to know which ones are doing better than others. So first, before I lose my concentration, I want to give you a couple conclusions. So do treatments consistently enhance understory components? I think yes. For the most part, bare ground is going down, and these are the most consistent things that we're seeing. Litter, perennial grasses, and shrubs tend to increase. But as pointed out, some of these shrubs may not be ones we want. Okay. Perennial forbs primarily increase for mastication and chaining sites, which are typically in the later phases of woodland expansion. Okay, so does recovery depend on site potential? Yes. I think shrubs and perennial forbs increase primarily on the PJ ecological sites. So these are woodland sites, and that's their potential based on the NRCS's ecological site inventory system. Perennial grasses increase basically on all ecological sites, though. And how effective are seeding treatments? I think we can conclude with a high level of confidence that seeding greatly enhanced perennial grass cover, but perennial forb and sagebrush cover did not vary between seeded and unseeded sites. So that really kind of gives us kind of the impetus to look very closely at the seedings. Which species are doing well, which ones are not performing as well as we'd like. And so what I'm going to do is kind of jump you into an analysis here, and it looks like I've been cut off a little bit. So you're familiar with this type of a scale here. I've flipped the axis now, so you're looking at the same zero line, and what we're going to be considering is the establishment of different shrub species here in two different treatments. Okay, we have the mastication treatment and then the chaining treatment. You can't see it, it got cut off. Okay, so the open symbol is the chaining treatment. Hopefully that doesn't throw us off too much here. Okay, and what we're looking at here are 4 different shrub species. Now keep in mind that the mix of species that are seeded at each site are all over the board. But what we did is we drilled into the data set and we tried to find a common set of species that were seeded on a lot of the sites so we could learn about them. Okay, so let's look at the shrub species that were seeded. Okay, and keep in mind here, this is at the longer time frame. So this is not just the first 3 years of establishment. These are sites that have been monitored between 5 and 10 years after being seeded. And so hopefully that'll add a little bit more strength to what I'm showing you here. And first off, you can see that, you know, and based on what Kevin was saying earlier, this is based on density here, okay? So what we're seeing is that the density of sagebrush plants is increasing in both treatments after 5 to 10 years in these treatments. And here's a native shrub, four-wing saltbush, and here's an introduced shrub called forage kochia, and then bitterbrush. And you can see that there are some very distinct treatment differences here. Just to give you an idea, if you've ever worked with forage kochia before, you kind of know that it likes bare ground. It's almost like a salsola species. It likes its bare ground, and when you're doing mastication treatment, you're creating a bunch of litter, and that species is not going to do too well there. Okay, but when you have a little bit more disturbance associated with chaining, you can see that that's why that species is doing so well. But it's the exact opposite for bitterbrush. You can see that there are certain treatments where bitterbrush does better. So, you know, we're learning here in the process. All these forbs are introduced forbs, okay? And you can see that in the mastication treatments, you can see that they're generally better. This is a small Burnett. You can see that it's doing quite well in both of the treatments. So, you know, that's one of the heavy hitters that's put into these seed mixes. It establishes well and it persists. Some people might say it doesn't persist more than 10 years. But this data set goes up to 10 years and it's still there, okay? But the interesting thing here with the grasses is how well they establish. We kind of already knew that from the previous data set. But there are certain species that don't appear to be doing too well. NS means not seeded. So what that means here is that western wheatgrass, I'm just going to use the codes here because words are too long. This is western wheatgrass. It was never seeded in the chain sites. Whereas, you know, this is Russian wild rye, an introduced grass. It wasn't seeded in the mastication sites. So you can kind of see that in some cases we don't have the full contrast of treatment. But I think across the board you can see how well most of the species that we're assessing here are doing. Okay? A couple of exceptions would be Poa secunda, Sandberg bluegrass in the chain sites don't seem to be doing well. Blue bunch wheatgrass doesn't seem to be doing too well in the chain sites, as well as intermediate wheatgrass. All right? So that kind of gives you an idea of how we're trying to delve into the data set a little bit more and identify which species and which treatment combinations. Now this is just the pinyon juniper treated sites. Keep in mind we have, you know, over 100 sagebrush sites where we're doing similar types of analyses, just to try to get an idea of treatment responses and the effectiveness of the seedings. So we can also look at some other interesting things here. If you pool all the grasses, all the forbs, and all the shrub responses together, you can generally see here that in the establishment phase, after the first 4 years here, you can see that in general, all three of those functional groups, if I can use that term, they all established quite well, and they all persisted. So I guess my conclusion at this point would be that the seedings are working, and when you focus on species that didn't necessarily exist on those sites before they were seeded, you can see that the effort put into seeding is working. Another way to kind of look at this, because a lot of us are kind of cued into this hot button of what's the origin of species? Are they introduced or are they native? As you've probably recently heard, a lot of the federal agencies got together and they have a native seed strategy, how to develop the seeds necessary for restoration, and there's going to soon be policy that's going to be pretty strict on the use of plant materials. And hopefully this type of information can feed into those decisions that we make, and you can kind of see across the board, and we kind of already knew this, after all the years of development of introduced species, breeding, and seed quality, and all the effort that's been put into them, they tend to do a little bit better. But what does better mean? I mean, it looks like the native species are establishing too. So I think we're making big gains with these new plant materials, the new native plant materials that are being developed, and that's a real win for us because the majority of these plant materials are actually being developed within partnerships right here in the state of Utah. And the nice thing is that the grasses and shrubs are definitely persisting, the ones that are seeded. That's a good sign. So I can stop here, or I could give you guys some more future directions. But I want to make sure we have enough time to answer some questions. And if one of those questions jumps into what we're going to be doing in the future, then we can go forward a slide.
Question about the annual grasses taken off in the mastication sites. I guess I wouldn't have expected that because it seems that there's a lot less disturbance there than there would be in something like a chain. Wondering why. What's going on there? Yeah.
Yeah. See, that's the big problem that we're having is that we're seeing the responses at this point. Now we have to come up with a hypothesis that deals with the mechanism, and as we drill into the data, we might find that there's certain patterns that are emerging. That's where we really need more scientists to help us out with describing these patterns.
So it's nothing obvious like they're all taken off in the tracks of the masticators, or
what do you think?
I guess I would postulate that when we were contrasting those three different treatments, and we have the lop and scatter, which are usually, that was the one that we didn't see the cheatgrass take off. But most of those sites, what we're doing is a preventative treatment, and we haven't lost the understory that's there usually. But these mastication and chaining, we've already lost what's there, and so there's a bigger chance for invasion to occur. And anytime you do disturbance with cheatgrass, it's going to thrive. So
yeah, it's there, and your opening resource would be primary.
the idea is to compete with perennials that we're seeding.
And you haven't reestablished that perennial base yet to compete, which is a hopeful sign of that trend to me of, it does have that initial burst, but then you see that rapid decline in the following years, and I would postulate again without having the direct answer that's that perennial competition coming in there. So.
Yeah, just keep in mind that these sites are starting in different condition, and we're working on ways of teasing out some of these effects. I gave you just one brief example of how we're dealing with the site potential, but it's just obvious they're on different sites, but the condition of the sites, and there's a reason why they use mastication, as Danny pointed out. understory is pretty bad shape.
You mentioned sagebrush seems to struggle with seeding. Some of the guys at Great Basin, I don't know if it's Danny or Kevin or Jason or somebody showed me a table once of the effectiveness of different seeds of sagebrush. And some of them seem a lot better than others. I don't remember who showed me that. But, you know, I think it goes back to maybe rather a generalization of sagebrush seed doesn't work that great. Maybe is it the right seed in the right place?
Yeah. Well, I was excited to see that sagebrush is establishing and persisting.
Yeah, but it seemed like you said it wasn't as good as what you've seen with some of the other, the grasses and things.
Yeah,
Or did I miss it?
when you base it on cover, it's difficult because the cover, as these folks know, you're using a tape and you're doing line intercept and you might be missing all the little ones. When you base it on the frame on the ground, you're picking up the density of the smaller ones with a little bit more accuracy, I think.
Probably might also be worth pointing out, I mean, this treatment is, you're attacking trees. There's enough resources there to grow trees. Means there's enough precip. Might be having a hard time establishing sagebrush in harsher sites that don't get enough water to grow trees. That might.
Yeah,
Part of what's
these would be a higher potential, but
Right.
there are Wyoming sites in this study, but they are the higher potential Wyoming sites, so that would probably, that's a valid point as well. And the things you're alluding to are some of the studies coming out, it's a little different than this, are that the sagebrush seeding treatments aren't working in the lower potential sites. And I think there is probably some validity in what you're saying of more locally sourced in those sagebrush areas to make sure that they're adapted to those sites, in the persistence particularly. So it's a little bit different than what this study was looking at, but yes, it's a very valid point. So.
Did any of these treatments involve herbicides? Did you do any?
I didn't really get into it, but there is all the sagebrush sites that we're focusing on 3 different treatments. And we're focusing on the aerator, the Dixie Harrow, if you're familiar with that tool, and fire, because they're the most representative ones that have a lot of sites that can pool data, not necessarily pool data, but to create a lot of different statistics that I've shown you here. But herbicide is commonly used. Maybe not so much in this particular data set, but we've chosen not to go after those immediately. Kevin, you may have a better idea of if anyone else is focusing on herbicide.
We're looking into some plateau stuff, but actual like toward spike and things we haven't looked at. We have fewer of those sites, so running a meta-analysis on them is more difficult. We don't have the replication to do it right now, I don't think.
For these particular sites, for pin and juniper sites, it's pretty rare to do seeding or spraying plateau herbicides on them. But more just with large cheatgrass invaded sites, they do get sprayed.
Yeah, so hopefully this gives you kind of the early framework of how we're dealing with some of those challenges I outlined and moving forward with manuscripts so we can get some of the word out and then make the database accessible to other people who can really kind of find something that they want to explore a little bit closer. We currently have a graduate student studying the seedings, and then starting on November 1st, we have a postdoc coming on board to kind of get at some of these mechanisms.
And they're focusing almost exclusively on the individual species level response,
Yeah, they're
correct?
going down to the species level, but whenever you want to do, the species level, you naturally want to start pooling stuff together to look at these types of broader implication responses.
Any early indications on why blue bunch isn't established?
So, going back to your slide, now, these sites were only sites that did not have blue bunch on them prior to, correct?
Not necessarily.
Oh, okay,
Not
okay.
necessarily.
That becomes difficult in
Yeah.
monitoring to separate the seeded from the unseeded, so yeah, that's another one of those dirty things in the data.
Yeah, I don't know why. The seed's good. We have great quality seed.
Sources from outside the Great Basin.
Yeah, that could be part of it. So Danny's suggesting that maybe a seed that might be more local to the Great Basin might be more adapted.
Do we have any collections yet to work on?
And we've been working with one of Tom's colleagues, Blair, with the Great Basin Blue Bunch Wheatgrass. It's been a long process, but it's being developed.
It takes about 10 years to go from collection to release, if you're lucky. What I mean by release, that is, have a variety that's sourced and you can purchase on the market, you know this. It takes a long time, especially if you put a lot of work into the species. If it's just kind of a source identified plant material, and you say, oh, this is where it came from, you do a little bit, maybe a little bit of testing, you can get them out quicker. But when you ask a plant breeder just to go collect something and release it, they're usually want to spend some time working on it. They're not modifying the genome. What they're doing is just selecting the best alleles within the populations. And they might be working on obvious things like seed shattering issues or other seed quality, dormancy issues. There's a lot of background work that goes into these. But we're seeing huge improvements in the native grasses and forbs that we're developing, which is promising. Now we just have to get enough seed to be involved in these types of studies.
What
Nate?
is,
Oh, sorry.
Tom, sorry, is, when looking at these seeding successes and going future with the graduate student and the postdoc, is it gonna be evaluated with moisture received that year compared to
Yes.
average?
I'm glad you asked this, because that's actually one of the future directions. So we're actually developing models where we incorporate, site, slope, aspect, environmental variables like precipitation, calculating new variables. We've already done quite a bit of modeling to pull out the best predictors of success at the functional group level. It's going to take a little bit more to get down to the species level, but that's where we're starting right now. And hopefully this postdoc that'll be starting here on the 1st of November can really kind of sink her teeth into that. That'll be her duty to take these models a little bit further. And we're also doing a lot of community analysis with these data sets because we have every species in its abundance. It's really a rich resource to do whole community analyses. So we're actually tracking the trajectories of these plant communities. And we're looking at the trajectories. Maybe I'll just show you really quickly. I don't want to get too far into it, but here's an example, because you asked about box elder. Here's 50 sites up in box elder where Mesmer's group has provided us some data, and we're starting to look at just what are some of the successional trajectories of different PGA-treated sites. And I don't want to get into too much detail here, but just think of these connected dots as where did the plant community go over time, okay? And you can see the control areas here on the right in the blue. They're different than the treated areas, okay? And we're trying to attribute certain environmental factors to what's really driving these changes. Keep in mind this is just really rough and dirty right now. We're starting to see some patterns fall out with treatments. And keep in mind that this data set isn't ending. We're going to keep adding to it we might find that things are just circular and they come right back to where they were. But we'd like to know how long it takes to do that. So that's one of the second future things we have here, is to kind of evaluate the longevity of these treatments. When do we have to retreat again? Maybe they're gonna be self-sustaining and they don't need to be retreated. Who knows? And because we've teamed up with some more wildlife people, we're very interested to see what type of time frame it takes to meet certain guidelines for wildlife species.
So how do you evaluate land use practices that are ongoing at the same time that you're monitoring these things?
How do you pull that? Yeah. Well, you guys are just feeding me these questions. Let me give you an example. Sometimes sites have had a treatment that went in ahead of time. And we call these types of effects legacy effects. I'm interested in this because we've been studying it in dry farmed areas in the valley bottoms. We've been doing that for a number of years. But sometimes we find out that sites have a history, and we can pull some of that out. Whether we can pull out something as sporadic as grazing, I don't know. That's Kari Vevlin's on my team, and she's currently looking at that right now. But some of the lowest hanging fruit that I could find was knowing a little bit about the sites, because I know people who are good at reading the landscape and digging into land use history. Just by knowing land use history, for instance in this case cultivation, we can see the different patterns start to emerge. And in this example here, you can see the non-cultivated sites. Now, keep in mind, a lot of sagebrush land was cultivated in the past, but then it was abandoned, and what we're dealing with is the succession that happened after that. Some of them might have been seeded and some of them were not. But you can see what I'm working on this study right now, where a collection of these WRI sites have been cultivated in the past, and they're all on the same ecological site. So I can start to look at broad patterns of how these communities respond to a treatment. All these sites here were treated. This is where it was before treatment, and here it is after treatment. So the magnitude of change, that's the topic here, magnitude of change is much greater in these non-cultivated areas. And these are just broad categories that are responsible for this pattern. So you treat a site, sagebrush cover goes down, perennial grass cover goes up. We already kind of knew those would be the main axes, but there's some other details in the story that we're going to try to tease out. But ongoing management, the grazing return, what's it going to do? Well, they're still monitoring them. I guess hopefully we can pull it out. Does anyone have any experience in doing that? I'm open to ideas. But that's a good question, because keep in mind here, a lot of these sites are going to be used still. That's why they spent the money to treat them. Any ideas?
We had a tough time doing that in Rich County. I mean, we knew gross treatments when we did that up there. Absolutely no matter how much digging Julie did, we could not find out how many friggin' cows were on any given area and the intensity and duration of grazing. And that was the biggest kicker we had up there, trying to figure that out. We had no idea of how much herbicide was dumped, so we don't even know if it was,
when it was dumped.
Well, within decade we've had it. That was, no, you can laugh, but that was, and oftentimes it was an old 7.5 minute quad that somebody drew a circle. And, so it's hard to pull that legacy stuff together.
It is
and
tough.
all that noise just.
Well, a lot of it's
gets
trying to understand,
locked
every
in there.
plant responds differently to different pressures, and trying to understand the intensity and duration of those pressures on individual plants, because they respond differently, each species.
The other funny part is that upper right-hand corner, because we found very, very few acres that had not been manipulated or
in some way.
at some way,
Oh, sure.
form, or another. And then you have all that background, you don't know with that initial condition, and then that gets commingled with people saying they looked at the condition 20 years ago, and then that's how they defined the site potential.
Right.
not knowing that that may be a legacy effect from something, and so then all this gets mushed together. It's tough to tease it out.
Yeah.
Your hair will be like mine by the time you get close to
You know,
finishing it.
that's the kind of stuff that'll keep us up in the,
Yeah.
but these are really good questions. I'm excited about the potential because, you know, the real take-home message here is that a lot of hard work and effort has gone into this. It's a team effort, everyone's willing to play, everyone wants to get involved. Sorry, anyone who wants to get involved can get involved. There's no ownership here, it's all public knowledge. But this is just gives you an idea of how we've chosen to kind of get started.
Any other questions for Tom? Okay, thanks, Tom.
Coming back to talk first treatment. A couple months.
Feel free to grab a couple of cookies and take back to your office.